So once more, very good morning to all my dear students. I welcome you all into the industrial pharmacy first. So dear students, today we will go through another topic which is said to be the pellets. Now what are these pellets? Do you have any idea as far as the pellets are concerned? Again, it is a kind of dosage form. Then why there is a need to have these pellets when we will be having the tablets, when we will be having the capsules, when we will be having the oral liquids, when we will be having the parenterals, ophthalmics, topicals? Why there is need and what are these pellets? So all these things we will going to come to know through these slides. But before that, you might have seen the or you might have taken the treatment of the homeopathy, isn't it? You might have taken the capsules of the cold acts, isn't it? Now, what are these uh, treatment or what are these medicines that are given by the homeopathy physicians, homeopathy doctors? That is nothing but the pellet, right? So there is a central core material. Onto this core material, the solution or suspension or the powdered material, that might be drug substance, or that might be the solution of the drug, or that might be the solution of the liquid or the suspension of the liquid drug, or there might be a solution or suspension of a drug which is going to be spread, which is going to be coated onto the small rounded particles or some spherical sugar balls, isn't it? So that is generally the treatment which is given by the homeopathy doctors. So that is the example of the pellet. And another, as I said, that you might have seen the cold act capsules, isn't it? Which are to be generally taken in case of the common cold, right? So what that particular capsule will contain, that capsule will consist of the small rounded balls. So these small rounded balls, these are nothing but the pellets. This is just for understanding purpose. Now what it is, what is its official definition, that we will going to come to know. But this is just in order to draw your attention toward the pellet, what that particular dosage form is. Now what is the need to go for designing and developing the pellet kind of the dosage form? The necessity or the requirement is that when the quantity of drug is very low, or the when the drug is very potent, then in that case it is the best delivery system in which the pellets are going to be used, and the drug that is going to be either coated or sprayed or suspended or onto that of the central core material. So when the drug is potent, when the quantity of drug is very small, in that case highly it is preferable, which is not possible with that of the tablet or the capsule kind of the dosage form. That is what the pellet means. Okay, so this is just the general discussion. Now let us see that what we will going to study in the coming slides. So we have to go through the what the pellets are. Then we have to see the different technique by which we can go for the process of formation of the pellets. That technique is said to be the pelletization, and the different technique which are used, these are said to be the pelletization technique. Then we have to see the various methods of pelletization, the various techniques by which we can go for production or manufacturing of these pellets. So that is what is the expected to know or to learn in the coming slides. In order to understand all these, we have to go through the introduction to the pellets, then methods of pelletization, and the different kinds of the equipments which are used in order to prepare or in order to produce the pellets. Now, pellet, what the pellet? Pellet has been described as a variety of the agglomerate. What it is? It is the agglomerate. Agglomerate is what? Agglomerate, that is nothing but the uh, coagulation, or instead of using the word coagulation, it is the aggregation of the small particles, powder particles. The aggregation of the small powder particle, that is nothing but the agglomerate. These are produced from the diverse raw materials. So in order to produce this, we have to go for use of the various kinds of the raw materials. You can see in this particular picture, there is a natural ophthalmic, which is the one of the product, that is the floater pellet. And you can say this is the homeopathic medicine for the oral use, the professional strength available via the doctor, and whatever the quantity is there that has been given. So you can see here, there are small rounded balls. You can see here the content is 1 ml. That means that particular quantity of the drug that is going to be spread, that is going to be made available in the form of all these pellets. So these are going to be produced using different pieces of the manufacturing equipment. So in order to produce this pellet, we have the different kinds of the manufacturing equipment. Now, what the pellets are? Pellets are nothing but the very small, free flowing spherical particles, right? What their size is? How much? Their size is very small. How these are? These are free flowing. As these are rounded, as these are spherical, these are free flowing, and these are the particulates. These are manufactured by the agglomeration of the fine powders or granules of drug substances and the excipients. As already I told you that this is the agglomeration. This is the aggregation of fine powders or very fine granules that will be brought together, that will be held with each other, that will be held together with the help of a and these granules or these powders are of a drug substances, or sometimes they may contain the excipients also. So the pellets, these are the small rods with the aspect ratio of close to unity. Then these will be having the high degree of flexibility in the design. So we can go for manufacturing of any size, of any design. That might be spherical, that might be rounded, that might be oval, that might be elliptical, isn't it? Any kind of shape that can be given, because these are very small in size. These are very small. These are developed that involve the development of the oral dosage form. So these are taken by the oral route. So that's why these are the oral dosage form. And the desired dose strength without formulation or the process change. We can go for altering the dose strength. Either, let's say for example, if it is the kind of, or if the core material is there onto which solution or the suspension is there, if we just go on altering the concentration of the solution or suspension, we can go on altering the desired dose strength. So desired dose strength that can be altered without formulation or the process change. We need not to go for altering the whole process. Just simply we need to go for increasing, or we have to increase the concentration of the solution or suspension, or the strength which is to be added into the powder. We can get the pellets of the different dosage strengths. And we can give the incompatible bioactive agents like say proteins and the peptides with the help of these uh, pellets. So what are the pellets? Again, these are taken orally. These are dispersed freely in the gastrointestinal tract, and there is a maximum drug absorption. The pellets, they will lead to the maximizing the drug absorption because of their small sizes. The surface area that is getting increased, and at the surface area is getting increased, that is directly proportional to that of the rate of absorption. So the indirectly pellet that will goes for increasing, or that will goes for having the faster absorption rate. If you just compare with that of the tablet, they will be having a precise size. Now, in the size of tablet, the surface area is very small, but in the content of the tablet size, if we go for the pellets, that pellet will be having the very larger, or multiple times of that of the tablet. There is a surface area. They will minimize the local irritation of the mucosa by certain irritant drugs, because the quantity of the drug very small. They will reduces the inter and the intra patient variability. Now, if we see the different processes, the pelletization, what the pelletization is? Pelletization, these are nothing but the process by which the pellets are going to be produced. So what are the different pelletization processes? You can see into this particular screen, onto this particular slide. There are various kinds of the technique, but the most common out of all these, that is the very first one, that is the powder layering. The second, that is the solution or the suspension layering. And the third one, that is the extrusion spheronization. These three are the most common and very widely used technique. Now, in addition to all these, there are some four more techniques. These are said to be the spherical agglomeration or the balling, spray congealing or the drying, cryopelletization, and the melt spheronization. But in case of the powder layering and the solution or the suspension layering, there is a particular core material. Onto this core material, in case of the powder layering, the powder material that is to be sprayed, and that is so that the layers of the powder that are going to be added in order to increase the size of the core material. In case of the solution or the suspension, the solution or suspension that is sprayed in the form of the different layers in order to increase the size. And in case of the extrusion spheronization, the material that is going to be passed through the orifices in order to produce the small balls or the small spherical particles, which are said to be the pellets. Now, what these and how these are going to be produced, what are the equipment that are used, we will go through that one in sufficient details in the coming slides. So the first, as I said, that is the powder layering. You can see, let us say, for example, this is the core material onto which the powder that is going to be sprayed. Now, in order to spray this particular powder, there is a binding agent. So, binding agent first of all that is going to be sprayed, then the powder that is going to be sprayed. So, with the help of the binding agent, the powder that is going to be adhere onto the surface of this core material. So, the powder layering that will involve the deposition of the successive layers of the dry powder of drug or excipient or both. So, this powder that may contain drug, that may contain excipient, or sometime that will contain both, that is the drug excipient both. On preformed nuclei or the cores, you can see these are the preformed nuclei. These are called as the core material. Onto these core material, the powder that is going to be spread in the form of the successive layers with the help of a binding liquid. So binding liquid, that is most important in order to bind onto that of the nuclei or the core material in order to form the bond, the binding liquid that is going to be used. Because powder layering that will involve the simultaneous application of the binding liquid and the dry powder. So with the help of the binding liquid, the powder that can be adhered, the powder that will stick onto the nuclei and the core material. So it generally requires the specialized equipment, some specialized equipment. As you can see, there is a perforated sieve onto which the core material that is going to be placed, and there it is going to be sprayed, the liquid and then the powder. The powder layering that will consist of the particular product container with the solid wall and with the no perforations. Earlierly, the coating pan, the conventional coating pan, which already we saw in case of the tablet coating processes, it was the very first equipment that was used for the process of the powder layering, the conventional coating pan. The elliptical pan that will tend to a fewer stagnant spot than do the cylindrical pans. And consequently, there is a reduction into the tilt angle that will decreases the formation of the dead spots. So the dead spot, that is nothing but the particular spot where there is no addition or where there is no uh, spraying of this solution and adherence of the powdered material. If the rotational speed of the pan is too slow, segregation may occur. So there is a need to have the optimum speed with which the pan that will goes on rotating. If the rotating speed of the pan that is too much slow, then the segregation that may occur. Then the powder layering that will involve the prolonged contact time among the particles that could favor the particle agglomeration. So the area where there is a binding material, and if it will come in contact with that of the powder, so that will lead to that of the agglomeration of the particles, agglomeration of the powders. Binding solution and a finely milled powder, these are added simultaneously to a bed of starter bed at a controlled rate. So continuously and the simultaneously there is need to add the binding solution along with that of the powder in order to ensure the uniform layering or onto that of the nuclei or onto that of the core material. In the initial stages, the drug particles, these are bound to the starter seed. Starter seed, that is nothing but the core material. Starter seed, that is nothing but the nuclei to which the binding material and the powdered substances they will attach. Subsequently to the forming pellets with the help of liquid bridges originated from the sprayed liquid. Then the liquid bridges, these are eventually replaced by the solid bridges. So the liquid, as the liquid that will comes in contact with that of the powder, so this liquid bridge that will get replaced by the solid bridges that are derived either from a binder of the application medium or from any material. So the binding to the binding material, the powder material that will add here. So the liquid that will get converted into the solid bridge, liquid bridge that will get converted into the solid bridge. The successive layering of the drug and binder solution continues until the desired pellet size is reached. Right. So when the required the desired pellet size that is going to be reached at that time, the particular uh, what to say the pellet that is going to be obtained. So how it is going to be obtained? It is going to be obtained by giving the successive layering of the drug as well as of the binder solution in order to produce the pellets of the desired size. To deliver the powder to deliver the powder accurately at a predetermined rate and in a manner that maintains equilibrium between the binder liquid application rate and the powder delivery rate. As I said that this should be optimum, so the rate of addition of the liquid and the rate of addition of the powder that should be controlled, that should be predetermined, and that should be in a regularized fashion in order to obtain the pellets of uniform layer, uniform size, uniform shape. That is the thing. The rheological properties of the binding liquid, the liquid application rate, and drying temperature that should be optimized. The rheological properties, the viscosity, it should not be too much viscous, which is very difficult to spray. It should not be too much uh, less viscous, or it should not be too much liquid so that it is very difficult to spray and that will lead to that of the more wetting, right? So everything that is the rate, that is the rheological property, that is the viscosity of the binding liquid and the liquid application rate and the drying air temperature, everything that should be optimized one. The powder should be delivered at a rate that maintains a balance between the surface wetness of the cores and the powder adhesion, right? So the rate, there should be a proper balance between the rate of addition of the powder and the surface wetness. If the powder addition rate is too much slow, so that will lead to that of the too much wet surface, that will lead to that of the agglomeration or the adherence or forming the larger aggregates of the pellets. Or if the rate of addition of the powder is too much high, so again that will not allow to adhere sufficiently the powder onto the surface. It should be uh, optimum, it should be controlled one, right? So it should be adjusted one based on the requirement. So that proper balance between the rate of addition, rate of drying, rate of adherence of the powder, that should be maintained. If the product bed temperature is high, the powder is lost to the exhaust system, isn't it? If the product bed temperature is high, the product is lost to the exhaust system. If it is too low, that means if the product bed temperature is low, it leads to agglomeration and or the formation of new nuclei that serve as core for the further layering. So here in this diagram, you can see there is a schematic representation which has been given as far as the centrifugal fluid bed equipment and the process with a single walled product chamber is concerned. You can see there is A diagram, there is a B diagram, there is a adjustable disc. In case of A, the disc is adjustable. In case of B, the disc is not adjustable. It is fixed one at a fixed height and it is rotating. This disc is also rotating, but this is adjustable rotating disc. This is fixed rotating disc. This will go on rotating into this side, into this direction. This will go on rotating into this direction. Their speed of rotation that can be controlled, that can be altered, that can be modified. You can see in A diagram, there is a nozzle from the side, whereas in case of B, there is a nozzle from the inside. And here there is a fillet bed. From the bottom, the air, fluidizing air that is going to be introduced from the slits from the sides, and here also the fluidizing air that can be introduced from the bottom. Only the difference is the adjustment of these nozzles and the disc. Here the disc height that can be adjusted, sorry, here the disc height cannot be adjusted. Here the disc height that can be adjusted. That is only the difference. So this goes on rotating, and as it will goes on rotating, with the help of introduction of the air from the bottom, the pellets that will float, that will get fluidized, and out of which the mm, solution or the suspension that can be sprayed, or the powder that can be sprayed. So that is the equipment which is used for the process of the production of the pellets, right? Okay, next, the another technique which is said to be the solution or the suspension layering. So this solution or the suspension layering, that is the process which is said to be the Worcester coating processes. Worcester coating processes. Now this Worcester coating processes that was invented about 30 years ago. It is invented around 30 years ago. It is the too much old process. The cylindrical partition that is located in the product chamber and the configuration of the air distributor plate is also known as the orifice plate. So that will consist of a plate which is said to be the orifice plate. That orifice plate will contain the holes, and through these holes the air that is going to be introduced. The latter is configured to allow most of the fluidization or drying air to pass at high velocity around the nozzle and through the partition, carrying with it the particles that are being layered on. Once the particles they will exit the partition, they enter the expansion chamber. Here the velocity of the air is reduced below the entrainment velocity. Entrainment velocity is nothing but the velocity which is at its entrance. And as it will move away from the entrance, its rate that will goes on reducing. The particles they will fall back on the onto the area surrounding the partition referred to as the downbed. The downbed is kept aerated by the small fraction of air that passes through the small holes on the periphery of orifice plate. At a given load size and fluidization air volume, the partition height can be reduced or increased to provide either a well-controlled particle motion. It provides the it produces the desired pellet movement or a bubbling downbed, which leads to the disorganized particle movement and inefficient processes. The disadvantage of the Worcester processes is the inaccessibility of the nozzles. If the nozzles are clogged at any time during the layering processes, the operation has to be interrupted. The operation has to be stopped, and the spray guns must be removed for the cleaning. Multiple nozzles are used is multiple nozzles are used is the potential overlap of the adjacent spray nozzles, spray zones. The solution or the suspension layering is usually used when the desired drug loading of the pellets is low, because production of high potency pellet from low solids content formulation is not economically feasible. So you can see here, this is the diagrammatic representation for the Worcester processes.